This video is the next video in the algebra set of videos, and in particular, in this video, we're going to look at solving linear equations involving fractions. To begin, we're going to look at solving equations with just one fraction. Example 6.1 says, find the value of x in each of the following equations. When there's only one fraction in an equation, all you have to do is multiply every term in the equation by the denominator in the fraction. This is best explained by going through A, B, C, and D. To begin here with A, we have x divided by 4 is equal to 3. To get rid of the fraction in this equation, we just need to multiply both sides by the denominator of the fraction. Here, the denominator is 4. Therefore, we can multiply each side by 4. On the left-hand side, we have 4 multiplied by x divided by 4. The x has been multiplied by 4 and divided by 4, so essentially, it's been multiplied by 1. We end up with x is equal to 3 times 4, and 3 times 4 is 12. The next example, B, is very similar. We have 5x over 3 is equal to 10. Again, we have to figure out what x is equal to. To begin, we need to get rid of the fraction. The fraction here is 3, so to get rid of the fraction, and because there's only one fraction, we can multiply both sides by 3. Multiplying the left side by 3, we end up with 3 by 5x divided by 3. The 5x is essentially multiplied and divided by 3, meaning that it's essentially multiplied by 1. Therefore, we end up with 5x is equal to 10 multiplied by 3, which is 30. Next, we need to figure out what x is equal to. We have 5x, so we can divide both sides by 5 to figure out what x is. 30 divided by 5 gives us 6. Therefore, in this example, x is equal to 6. In C, we have 3x plus 7 over 5, and that's equal to 2. As in the previous two examples, we must find out the value of x. To do this, we first of all need to get rid of the fraction. To get rid of the fraction here, we just multiply by the denominator of the fraction. And both sides multiplied by the denominator of the fraction leaves us with 5 times 3x plus 7 divided by 5 is equal to 2 multiplied by 5. Now, on the left-hand side, we have 5 times 3x plus 7 divided by 5. So we essentially have 3x plus 7 divided and multiplied by 5, which is essentially multiplying it by 1, meaning we end up with 3x plus 7 is equal to. On the right-hand side, we have 2 times 5, which will give us 10. Finding out what x is after that involves taking 7 from both sides to begin with, so that we can have the x's on the left and numbers on the right. So we'll have 3x is equal to 3. And then we need to figure out what x is. We have what 3x is equal to. So dividing both sides by 3 will end up with x is equal to 1. Finally, looking at example D in 6.1, we have here x plus 2 all over 3 is equal to x plus 4. As in the last three examples, there's only one fraction in this equation, and to get rid of the fraction in the equation, we multiply both sides by the denominator of the fraction, which is 3. Multiplying both sides by 3 this time involves multiplying two terms on the right-hand side, which is x plus 4. On the left-hand side, we end up with 3 times x plus 2 over 3. The 3 times and divided by 3 cancel, as that is effectively multiplying by 1, and we end up with x plus 2. And on the right-hand side, we end up with 3 times x plus 4. Multiplying out the bracket on the right-hand side, we end up with 3 times x and 3 times 4. That will leave us with x plus 2 is equal to 3x plus 12. Now we have to figure out what x is. So to figure out what x is, we take 3x from both sides to bring the x's to the left-hand side, meaning that we'll be left with minus 2x plus 2 is equal to 12. On the right hand side, 3x minus 3x will give us 0x. Then we can take 2 from both sides and we'll be left with minus 2x is equal to 10. And then to figure out what x is, we divide both sides by minus 2 and we end up with x is equal to minus 5. Anytime you're asked to solve a linear equation that has one fraction in the equation, to get rid of the fraction, all you must do is multiply each term in the equation by the denominator of the fraction. This will get rid of the fraction and you'll be able to solve the equation as normal. The next type of equation you can be asked to solve is an equation that has 2 or more fractions in it. To do this, it's best explained by going through an example. Here, example 6.2 asks us to find the value of x in each of the following equations. To begin, in A, we have x minus 3 all over 3 is equal to x minus 2 all over 4. In this particular example, we need to get the denominator to be the same. At the moment, we have the denominator of 3 and the denominator of 4. To make these the same denominator, we have to get our common denominator. And our common denominator is usually got by multiplying the two denominators together, which in this case gives us 12. Then we write our new denominator, which is 12, and we figure out what the numerators will be as a result. In the fraction on the left, it was a denominator of 3 and is now a denominator of 12, meaning that we would have had to multiply the denominator by 4. As we've multiplied the denominator by 4, we must also multiply the numerator by 4, meaning we'll get 4 times x minus 3. On the right hand side, the denominator was 4 and is now 12, meaning we would have had to multiply the denominator by 3. Multiplying the denominator by 3 means we'll also have to multiply the numerator by 3, meaning we'll get 3 times x minus 2. Once the denominators are the same, we can forget about the denominators. We can solve the sum using just the numerators. Therefore, we'll end up with 4 times x minus 3 is equal to 3 times x minus 2. After that, it just turns into a normal linear equation that you solve firstly by multiplying out the brackets. You'll get 4 multiplied by x and 4 multiplied by minus 3 and 3 multiplied by x and 3 multiplied by minus 2. This will give us 4x minus 12 is equal to 3x minus 6. Again, we're going to bring all the x's to the left hand side. So I'm going to minus 3x from both sides, meaning I'll be left with x minus 12 is equal to minus 6. Next, I need all the numbers to the right hand side, so I'm going to plus 12 to both sides. Now, I'll end up with x is equal to minus 6 plus 12, which is 6. Therefore, the answer for A is x equal to 6. B is quite similar. We have x minus 1 over 2 is equal to 2x plus 1 over 5. Again, we need to get our common denominator, and we can find our common denominator by multiplying 2 by 5. Next, we get that 2 by 5 is 10, so our common denominator is 10. We rewrite each fraction with 10 as its denominator. Now, looking at the one on the left-hand side, we had x minus 1 over 2, but now it's over 10. So that meant we had to multiply the left-hand side by 5. If we multiplied the denominator by 5, we must also multiply the numerator by 5. Similarly, on the right-hand side, it was over 5, and now it's over 10, meaning that we must have multiplied the 5 by 2. If we multiplied the denominator by 2, we'll also have to multiply the numerator by 2 as well. Next, because the denominator is now 10 for both the fraction on the left hand side of the equals and the right hand side of the equals, we can forget about the denominator of 10. We'll be left with 5 times x minus 1 is equal to 2 times 2x plus 1. To finish this question, you solve the equation as you would with any other linear equation. For C, we have the fraction x over 3 plus x over 6 is equal to 2. To begin here, not all terms are over a fraction. What I like to do to begin with is write all terms as a fraction. We have x over 3 plus x over 6 is equal to 2 over 1. Now we can find our common denominator. And in this one, our common denominator can be 6 because both 1 and 3 can be changed to a denominator of 6. Writing it as a denominator of 6, we can see that the middle fraction, the x over 6, hasn't changed as its denominator was always 6. However, on the left-hand side, we have x plus 3, and that changed to over 6. Therefore, we must have multiplied the denominator by 2. If we multiplied the denominator by 2, we must also multiply the numerator by 2. So we'll end up with 2 times x. Similarly, on the right-hand side, we had a denominator of 1, and now the denominator is 6, meaning we would have had to multiply the denominator by 6. As we've multiplied the denominator by 6, we must also multiply the numerator by 6. Once we've done this, we can see that all fractions have a denominator of 6. As they all have a denominator of 6, we can forget about the denominator and just write the numerators, meaning we'll end up with 2x plus x is equal to 6 times 2, which is 12. Adding the like terms on the left-hand side, we have 2x and x, meaning we'll get 3x is equal to 12. And to figure out what x is, we divide both sides by 3, and we find out that x is equal to 4. Finally then, for D, we have 3x over 4 minus 5x over 8 is equal to a half. As usual, to solve this, we need to get a common denominator. The common denominator for this particular equation is going to be 8, as both 4 and 2 can be changed to 8 quite easily. The middle fraction is going to stay the same as it was over 8 to begin with. On the left-hand side, we have 3x over 4. However, the 4, the denominator part, has now changed to 8, meaning we must have multiplied the denominator by 2. If we multiplied the denominator by 2, we must also multiply the numerator by 2. The same can be said on the right-hand side. The denominator was 2, and now the denominator is 8, meaning we would have had to multiply the denominator by 4 to make it 8. As we multiplied the denominator by 4, we can also multiply the numerator by 4. After multiplying the denominator by 4 in the fraction on the right-hand side of the equals to, we can see that all of the denominators are now 8. As all of the denominators are the same, we can forget about the denominators and work with just the numerator part of the equation. We'll be left with 2 times 3x, which is 6x, minus 5x is equal to 4. That will simplify and we'll go 6x minus 5x, which will give us x equal to 4. After going through example A, B, C, and D, you should be able to answer any question where you're asked to find the value of x in a linear equation where there's more than one fraction. The most important thing to do is to find your common denominator. Then change all denominators to your common denominator. Once you have the common denominator, make sure you change the numerators too by looking at what was multiplied by the previous denominator to make the new denominator and doing the same thing for the numerator. Once you have changed all the numerators and denominators, you should be able to cancel or forget about the denominators as they should all be the same and only work with the numerators. Once you do that, the equation becomes a simple linear equation with no fractions. and you solve as normal. That brings to an end this video on solving equations that have fractions in them.